Welcome, Year 11 method students. This video is about Chapter 2F, Families of Straight Lines. When we're talking about families of straight lines, we are basically trying to find similarities or what is in common with the straight lines. Because the equation of a straight lines come with y equals mx plus c, this is the thing that we're going to be investigating. Okay, so now you can see here we have the gradient m and we have the y-intercept or the vertical intercept c, and these two are the parameters that we're going to be restricted. So if we restrict one, then all the graphs should have a common similarity or common feature. Okay, if we restrict one of these two parameters, the graph will showing a common feature. Now let's look at the first graphs that I use decimals to generate. Okay, now where you can see here, I have literally sketched 7 graphs. All of these equations that you can see have something in common. They are all missing the c, yeah? Missing the c, which is the vertical intercept. Okay, so when we're saying for this type of graph, we can write y equals to mx. Okay, so this is by investigating their equations, we find out that all of those equations does not having a c, or we can say c equals to 0. Therefore, we just write y equals to mx. Okay, the n is not restricted. That's why we have all different gradients, including 0. Now, from looking at these graphs, okay, where you can see all of these straight lines have different gradient, that's for sure. However, they all passing through the origin here, right? They all passing through the origin, okay? So therefore, we have the common feature for this family that's all passing through the origin. So this is the first family of straight lines. All right, now let's look at the second type. When we compare the first one and the second one, okay, so you can see this time the equation, okay, that all has the common vertical intercept or y-intercept here. Okay, so where we can expect here that all of those graphs are passing through the common y-intercept. Okay, passing through the common y-intercept. Again, this is sort of more general than the first family, the first case where you have restricted the y-intercept or being 0. But here we have restricted the y-intercept be our fixed numeral. Okay, so the number is fixed for the y-intercept, but it can be any number that you choose. So in this case, we would say that you can have different gradient of the graph, but all straight lines that will passing through the same y-intercept. Okay, so we're going to write in this form. So y equals to mx, that we don't know. We can choose whatever the gradient we want, but here we say they are all passing through 0, 3. Or we can say they have the same y-intercepts. Yeah. Okay, now let's look at the last family of the straight lines, where we can say this looked a little bit different, where you can say this time the y-intercept are different here. Okay, so we have 0, 10 here. We have this one is going to be pi. This one is 0, the origin, and this one is 0, -5. Okay, now where you can see that the y-intercept are all different according to the equations. They are all different. They all have different vertical intercept. However, this time we have restricted. They are gradient here. Okay, the gradient has been restricted. We know that in the previous video, chapter 2e, that we know if the gradient are the same, all straight lines will be parallel. Okay, and then this is the graph that we can see here. It's from showing the graph that we know it should be all parallel. Okay, so the common feature here is if you, for example, if you have restricted the gradient here, the m, all straight lines will be parallel. Okay. Okay, so these are the 3 families of in straight lines. Let's take a look about an example. Okay. So a family of lines having equations of the form y equals to mx minus 3. So from looking at this equation, we know that the y-intercept has been restricted, right? And here we say the m is a positive number, so we know that the m is going to be greater than 0. Find the x-intercept of a straight lines in this family in terms of m. Okay, so here we're going to ask to express the x-intercept. But we know that for x-intercept, you will have y equals to 0, right? Y equals to 0. So what we're going to do is we're going to sub y equals 0, and then you have 0 equals to mx minus 3, okay? And then you rearranging the minus 3, or you adding 3 both sides. So you got 3 equals to mx. And then because remember we're trying to find what x is, so we're pretending we know what m is, so we're going to divide by m, yeah? So that means 3 over m, it is equal to x. Or we say x is equal to 3 over m, okay? Either way. So that's part A. So look at the part B. So part B, it says find the value of m if the line passing through the point 5, 6, okay? So in this case, we know that there is a specific point, so which means the m is the only unknown. We can solve for m, yeah? So remember the 5 represented by the x, and x is the x coordinates, and the 6 is the corresponding y coordinates. And then we know that this point is going to be on the line. That means it should be satisfy the rule. Then we're going to sub this point, 5, 6, into y equals to mx minus 3. So we know that y is going to be 6 equals to mx, x is going to be 5, so it's going to be 5m minus 3. Okay, and then you're adding 3, adding 3. Okay, this is gone, so now you get 9 equals to 5m. So over 5 over 5. Note that m is equal to 9 over 5. Okay, m is equal to 9 over 5. That's the part B. Look at the part C. For which value of m is the x-axis intercept less than or equal to 1? Okay, so here we're going to get back to the first expression in part A that we get. So we have, now we know that the x-intercept, which is represented by 3 over m, is going to be less than or equal to 1, or less than or equal to 1, okay? So we also know that the m is going to be a positive number, so m is going to be greater than 0. We know that in linear inequalities, when we multiply our negative factor, we have to flip the sign. But in this time, the m is being positive, which means it's safe for us to multiply by m, both sides, by not changing the inequality sign in the middle, yeah? So I'm going to multiply m here, multiply m here. So this m is gone. So we have 3 less than or equal to m. Okay, or you can say m is greater than or equal to 3. Now let's do a quick check. So we have a number line. Okay, that's a 0, and then that is a 3. So previously we were saying that the m should be greater than 0 because m is a positive number. And now you have the m that is greater or equal to 3. So now we're going to choose this one, right? We're going to choose this one. We're going to choose this one because this one is satisfied for both, okay? For both inequalities, okay? Therefore, therefore, m is going to be greater than or equal to 3, okay? So as for part D, I'll put a D here. Find the equation of the line perpendicular to the line y equals to mx minus 3 at the point 0, negative 3. Okay, so firstly, in chapter 2e, we've talked about the perpendicular case, yeah? So the gradient of the equation of the straight line we're trying to find should have the negative reciprocal of the gradient of the line y equals to mx minus 3, yeah? Because they're all using the m, so I'm going to just write y equals to negative 1 over m x, okay, plus c. And then we also know that the point it's going to be 0, negative 3. So it's going to be that minus 3, yeah, minus 3. So here it basically tells you that the gradient, it is negative reciprocal, that they are perpendicular, but the intersection point is their common y-intercept, right? All right, thank you for watching. If you have any questions, again, come and ask me or come to Maths and Numeracy support. I'll see you at the next video.